Today's tutorial is about one of the trickier nodes in MOPs Plus, the attribute mapper. I say tricky only because the interface isn't like a typical node in Houdini and because it only works in tandem with the assign mapper SOP. It's a very handy and powerful part of the MOPs Plus toolset, and it's really not as tough to use as it might look, so let's just get started. The MOPs Plus attribute mapper creates relationships between attributes. You can think of this a little bit like a spreadsheet or like a lookup table. You have a simple key attribute that's usually just a number, and then one or more attribute values associated with that number. For example, in this screenshot here, 0 is blue, 1 is green, and 2 is red. In the screenshot here, we're actually associating those numbers with operator paths to materials. The attribute mapper is divided into two sections. The top table describes all of the attributes that you're generating and what their types are. In this example, there's two attributes being created, a float attribute called key and a string attribute called material. The bottom table describes the relationship between these attributes for any number of values. In this example, we have 3 rows in the table. A key value of 0 is related to a material value of blue, and so on. We can have as many of these rows as we want. Rows in the top table become columns in the bottom table, so you can see that there's a row for key and material up top, and then columns for key and material on the bottom, in addition to an index attribute that's automatically generated for you. It's a little confusing at first, but it'll make sense after you try it. The sibling node to the attribute mapper is MOPs Plus assign mapper. This is the node that actually reads these attribute associations and binds the values of one of these attributes to the points or primitives of your geometry. You first need to define the key attribute on the mapper, which is the value that you're going to look up. And then you define the local key, which is the attribute on the geometry that is affecting what's going to match the mapper's key attribute based on a simple rule like less than or greater than or equal to. Finally, you pick which attribute you want to read from the mapper, and then the attribute on the geometry that you want to set. For example, on the mapper, I have an attribute named material that pointed to a material operator path. I can read that value from the spreadsheet and then bind it to shop material path, which is the primitive attribute that Houdini natively uses to assign materials at the SOP level. The mapper can also automatically generate the syntax you need to override individual shader properties instead of just setting material paths. We'll get to that in a minute. First, let's start by building a simple example. Let's start by creating the materials we need. I'm going to start by making a geometry container, diving inside, and then let's make a material network. Inside, I'm going to create 3 principled shaders. We're going to call this one red. This one's green. This one's blue. Now let's just set some basic color values for these. So red is going to be almost pure red, same for green, almost pure green, and then blue. Now let's actually create some things to assign these materials to. I'm just going to create a box and then connect this to a MOPs instancer. And we'll just do this in a simple grid pattern. So I am going to change my global transform to 0.1 scale so that we have this nice even grid of cubes here. Now let's actually make the mapper. So when we first create this thing, we just have a generic attribute called attribute, and it's string type. And then we have this key attribute, which is an integer. And for this first example, we're just going to randomly assign materials, so we really don't need to worry about the key. But what we are going to do is change this string attribute to something slightly more meaningful. This just makes it easier to read. So to change the attribute name, I can just double click here and then type, we're going to call this material. Next, I need to create values for this material attribute. So I have 3 shaders that I want to randomize between. So I'm going to create 3 rows here. And one of the easiest ways that you can create rows is just by using either add from files or add from ops. You can manually create rows by hitting the add row button. But in this case, it's just going to be easier for me to select them this way. So if I hit add from ops, I'm going to get a menu that's going to ask me where to get these operators from. So inside that same matnet that I just created these shaders in, I'm going to select these 3 materials, enable export relative path just to keep things clean, and then hit accept. And now it's going to pop up and ask me what attribute, specifically what string type attribute, I want to be applying these operators to. And I only have 1 string attribute available, and it's material, so I'm just going to accept that. And now you can see it automatically populates the table with these 3 rows, 1 for each material that I selected. And each of these things are given a specific key value. Again, we're not using the key here because we're only assigning randomly, but this will become important later. If for whatever reason I wanted to change either of these values later on, I could double click and edit it manually, or I have these 2 little buttons on the side here. This one on the left is a file picker, so if I wanted to pick a file-like object, I could use this to browse to a path on disk. This is an operator picker, which more or less works exactly the same way that we did before. So if I didn't want to use MetNet1 Blue, I could pop this open and again have this operator chooser that I could use to pick a different path. I'm just going to cancel out of that. So now that we have this mapper assigned, this thing doesn't actually do anything by itself. It needs the assign mapper node to actually assign these properties to the geometry. If we were to visualize this, we can see that there's really nothing here. There's just points. And if you look at the spreadsheet, these points are actually storing these different values that we've created. Assign mapper is going to actually bind these point attributes to the geometry that we want to assign these properties to. So I'm going to create assign mapper here, and then the geometry goes in the left input and the mapper goes in the right input. Now, we're not going to see anything useful right away because we haven't picked the correct attributes yet. The material attribute that you use for assigning materials in Houdini, generally speaking, is going to be a primitive attribute. So I'm going to leave this where it is, and the match method is going to be random. And you'll notice that when this is random, the key attributes are completely blanked out. We don't need a key attribute because we're just assigning rows from that table completely at random according to a seed. So the only thing that we need to do is we need to pick our map attribute, which is going to be material. And this is the name of the attribute on the mapper that we want to draw values from. The destination attribute is going to be the actual attribute that we want to write to. And in Houdini, when you're trying to assign a per primitive material attribute, you use shop_material path. And this is just a Houdini convention. Once that's done, I now have this random grid of boxes where each one is given a different material from this material network, and I can change the seed to change that assignment. Okay, so that's the easy example. Now let's try to do something a little bit more fun. Let's say we want to directly use some other attribute to define what shader gets assigned to what cube. In MOPs terms, you would usually do something like this with a fall-off attribute because those are easy to generate. So this key attribute right now defaults to an integer, and it's a number that's just equal to the index, just the number of the table row. But we can switch this to be a float attribute just by hitting this drop down and going to float. Now you can see that the key attribute immediately starts being displayed as a float. But fall-off values don't go from 0 to 2, they go from 0 to 1. They're supposed to be normalized. So what I want to do is create sort of an even spread so that when fall-off is 0, it's going to assign blue, and when fall-off is 1, it's going to assign red. I could roughly do this by, let's say manually typing this in so that I do like a 0.3 here and a 0.6 here. And then if I go to the mapper itself and switch the match method to local key is less than or equal to map key, everything is going to turn blue because the fall-off value is the same on every node. So let's make a MOPS shape fall-off here. And then I'm just going to auto-fit it. And then what I need to do is my map key attribute is still key, but I need to set my local key to be that fall-off attribute. This basically means what attribute am I using to look up the table row on the attribute mapper. So I'm going to switch this to MOPS fall-off. And you can see that now I have this even distribution. But you can imagine that if I had an absolute ton of materials on here, then manually typing in all of these numbers for the key would be really irritating. So instead, there's this button called normalize attribute, which will essentially do exactly this for you. It'll evenly distribute any given attribute from 0 to 1 on these rows, assuming that you're going to work with a fall-off attribute to help with distributions. When you click that button, it's going to ask which float attribute you want to normalize. I only have one here, that's key, and then hit accept. And then it'll manually spread essentially the same values that I set before, but just a little bit longer because it's doing the math. And now I have a shape fall-off that will drive which material gets assigned to which object. So you can see if I move this around, it's actually going to update the materials as I go. Now, if I go to assign mapper, I could also go and change the rules to be, let's say, local key is greater than or equal to map key, and then get different results. You could also do an equals, although that doesn't work really well when you're comparing float attributes. Generally, this should be reserved for when you're matching to integers and not floats. Okay, now let's take this a step further. What I want to do is try to adjust the properties of a material instead of just assigning materials. So I'm going to create a new geometry container and dive inside. And Houdini has a bunch of different textures built in that you can use that are easy to use for examples like this. So I'm going to start by creating a grid and scale it way down, and then just give it 2 rows and columns. So I just have a flat quad here. And then I'm going to really quickly just assign UVs to it. And then let's pipe it through an instancer. I'm going to take the global transform again down to about 0.1. So I have this grid of faces here. Maybe I can make them a little bit bigger, just so it's easier to see. Okay, now I'm going to create a new material network because I want to make this material a little bit differently from the way that we did the last one. Inside, I'm going to create a classic shader. The only reason I'm doing this is because the principled shader and the classic shader have slightly different property names, and I want to point out the difference between them so that when you're trying to do overrides, you know to actually look at these properties. So the thing that we're going to override for these is the diffuse texture. So if I hit use map under the base color here, it's going to ask for this for an actual path to a texture map, and this is the property that we're going to override. When you hover over a property, you're going to see that it gives you the actual name for the property in the shader. It's diff_color texture. Remember that because that's the property that we're going to be affecting later. Otherwise, I'm just going to leave this alone. I'm going to turn off I'm going to set the base color to 1 just so that we're starting with white. Now I'm going to jump out and assign this material to all of my copies here. Make sure relative path is on. So now they all have this material on them and they start as stark white because we haven't assigned a map to anything yet. Now let's create the attribute mapper. So for this example, we're going to start by just assigning these textures randomly again, just to keep things simple. So I'm going to start by changing this attribute name to something that's more meaningful. I'm just going to call this diffuse. The name of this attribute isn't that important. It's really just whatever is easier for you to remember. Now, what I want to do is create a row for this for each texture on disk that I want to be using. So the add from files button is exactly what we're looking for here. This means I can select any number of files on disk and it's going to add 1 row per file I select. So from here, I'm going to go to HFS, which is going to point me to the Houdini installation root. And inside I'll go to Houdini, pick, and then there's all these butterfly images here. So I'm just going to grab, let's say, 5 of them, and then hit accept. Now, again, it's going to ask me which property I want to affect with this, and that's going to be diffuse. And now I get 1 row for each of these textures that I selected. Now, again, the attribute mapper, the assign mapper. And I'm going to start, again, match method random. Let's not get too involved yet. And then the map attribute that I want to use is, again, called diffuse. And the destination attribute is that shader property that I mentioned earlier. So that is going to be called diff_color texture. Now, you'll notice nothing changes, and this is because we're overwriting in a specific shader property. And under the hood in Houdini, there's a different syntax for doing this. If I look at my geometry spreadsheet, right now what it's going to try and do is create something called diff_color texture at the primitive level and set this property. But when you're overriding shader properties, specifically in Houdini, it doesn't want to see just any old texture or any old attribute name. What it wants to see is a specific property called shop_material override that's built like a dictionary, which means there's a set of key value pairs that say, here's the property that I want to modify, and here's what the value is going to be. This is kind of annoying to type out manually. So the assign mapper node gives you a little checkbox here called apply as material override. If you enable this, you can see that instead of just diff_color texture, which we can remove if we want to, what it's going to do is create a material override property that defines the name of the property we want to adjust and what we want the value to be. And you can imagine that typing this out manually would be a real hassle, and that's normally how you would have to do it if you weren't using the material SOP and a limited set of expressions in HScript to make it work, or using Python or something. So this is a very quick way to be able to vary shader properties without getting in the weeds with code. Now if we jump back to the scene view, you can see that we have this random texture assigned to each grid. And if we change the seed, it'll update. And again, we could go in here and assign a fall off value and then change our match method and then actually use, a shape or a noise fall off or really any other point attribute we want to affect which butterfly gets assigned to which card, which is pretty powerful. Now, at the time that I'm recording this, most third-party render engines support using the material override syntax. So Redshift, I believe V-Ray does, Mantra obviously does, but it's not always the case. And so there's an alternative way of applying these material overrides that you should know about. I'm going to disable this real quick so you can see that these squares are all going back to white. The other way of varying properties of instances per instance, and this is especially helpful when you're dealing with deeply packed primitives or more complicated sequences where you're trying to target specific properties of objects, is by using style sheets. Material style sheets are a bit complicated to go into, and I'd recommend reading the documentation on this. I don't want to go too far into how those work in this tutorial. But you should know that when you create one of these overrides, you can just click Generate Style Sheet. And what Houdini is going to do, and what MOPS is going to do, is create this extra property up on your object container at the object level called shaders. And if you go in here, you're going to see that this JavaScript syntax is created for a property called material style sheet or shop material style sheet. And this is essentially doing what that shop override did almost exactly, but it's just doing this in style sheet syntax. And any supported render engine is going to see this style sheet property on the geometry container and modify all of your shader properties internally at render time. Okay, let's take this same setup just one step further. I'm going to hide this network and just set up something similar once again. We're going to make a grid, make it 2 by 2 so it's just a plane, and then scale it way down. And then let's first add UV coordinates and then instance the result. And then I'm going to just scale this down on the global transform bit so that we can see the borders here. There we go. That looks good. And let's actually just add a few more. So I'm going to size up this grid to be 2 by 2 instead of 1 by 1 so we have a little bit more room to see what our randomization is going to do. Next, I'm going to create the material. And this time, we're going to go back to our principled shader. This is just to reemphasize that you need to pay attention to the name of the shader properties that you want to be changing, and they're dependent very specifically on the type of shader you're using. So if you're in Redshift, all of these properties are going to be named differently. For a principled shader, what we want to do is go over to Textures, and then enable the use of a base color texture. And then this is the property we want to modify. So base color underscore texture, remember that. Going to jump back out now and then use a material SOP to assign this new material to all of our packed primitives. And now let's create our attribute mapper. So again, I want to have two shader properties here. I want to have one that's going to be our string attribute that actually contains our texture. So I'm going to name this, let's just say texture. It can be anything you want. And I'm going to, again, add from files and grab 1, 2, 3, 4, 5. Let's do all 7 this time around. And then I'm going to assign this to texture. So now I have all my rows set up. But the mapper doesn't restrict you to just 2 attributes. You can actually create as many as you want and then either associate them directly with each other or assign them randomly if you want. So to create a new attribute in this table up here, you hit the plus button, and depending on which plus button you hit, it'll create an attribute in that same order, like directly below the sign that you hit. I don't really care about the order for this, so I'm just going to create a new attribute. And you can see that immediately I get a new attribute named attribute of string type that is going to be reflected down here. So each row here represents a column in this bottom table. And there's no values in here right now. We still need to assign that. But I don't want 2 string attributes. I could, but for this example, I want to do something a little different. So I'm going to change this to a color type attribute. You can see that what we get now are actual swatches. So let's change this to just be named color for now. We can call it whatever we want. We could call it CD directly to make it easier, but again, you're going to have to make that association yourself, so it really makes no difference for the purposes of the mapper. And now that I have these color swatches, what I can do is actually click them, and I'll get a color picker. So now I can just randomly, let's just pick some colors. It doesn't really matter what they are. And so now I have this row of texture paths and I have a row of colors. So let's assign them both. First, I'm going to make a shape fall off. And I'm going to use this to drive the butterfly texture path. So again, I'm just going to hit this really quick and then auto fit and then just preview fall off. So yep, got a good distribution. And now let's use the assign mapper to actually assign this butterfly texture. So again, on the mapper, I'm assigning primitive attributes because this is assigning the texture that we want to change. I'm going to change my match method again to local key is less than map key. My map key attribute is going to be key, and my local key attribute is going to be mops fall off. Now, the map attribute that I want to be using is called texture, and the destination is going to be the name of that shader property that we were talking about earlier. I forgot what it was too, so I have to jump back in here to remember. It's base color underscore texture. Base color underscore texture. And then I'm going to enable apply as material override. Now, what I didn't do is I didn't adjust the distribution of my key. So I'm just going to really quick hit normalize attribute. I need to change the key to a float. Normalize attribute, select key. And now I've got this nice and even distribution of all of these textures. And if I adjust the shape fall off in any way, let's say I just add a little bit of noise to it, you can see that's reflected here. I could even make it time varying. And now the butterflies just sort of randomly evolve over time according to that noise pattern. But I have more than one attribute here. So how do I assign that too? All you need to do is create another assign mapper. There's no need to create a second attribute mapper because we have all that data in that single spreadsheet. So I'm just going to chain it to the first one here and point it to the same attribute mapper. Now, I can just leave this random if I just want to randomly tint each of these butterflies with this new, with this color attribute. So my map attribute is going to be called color, and my destination attribute is going to be actually CD, which is the built-in point color attribute. And when I assign it to this, you can see that the textures are immediately tinted by this color. This is something that the principled shader does automatically, and a number of other shaders too. If you have a base color defined in the viewport, the viewport is going to read your CD attribute and use it to tint the displayed color. That's a viewport shader thing. And the shaders themselves, when you render, most of them have an option to either use a base color attribute or use a packed color attribute, and it will read that at render time. Generally speaking, though, if you want it to read at render time, it expects the attribute to be on your packed points. So when I do this, right now, by default, it's assigning this color attribute as a primitive attribute. You can see it right here. But generally, you want this to be a point attribute with packed points. So I'm going to switch this to point. And now if I look in here, I have a color attribute configured with these random values that I selected. And again, if I go in here and edit the seed, you can see that it's randomly tinting these things according to whatever colors that are assigned to each butterfly. For the last example, I want to show how you can vary something other than just material properties or basic point attributes. That's really powerful and handy to have, but varying instances is also something that can be kind of tricky to do. In Houdini 18, they introduced the variant attribute on the copy to point stop, which is great and very powerful, but it can still be a little bit tricky when you're trying to get really specific about what instance you want to go where, and it still means that you need to sort of define all of those relationships yourself by ordering your primitives and coming up with a way to pick which number means which primitive. It's not always the easiest thing to set up, and the attribute mapper can be used to do this for you really quickly. So I'm going to start by creating the objects that I want to instance, and that's just going to be something simple, like let's make a Tommy, a pig head, and a rubber toy. And just because that pig head is so enormous, I love it, but it's too big compared to the other guys, so I'm just going to use match size. And let's justify him and scale him down so he fits in a 1-unit box. That's a little bit closer. Okay, now that that's done, let's grab all these guys, throw them in a subnet. We're going to call this instances and just hide it so we don't have to see them on the timeline. Now, this is just one method of instancing. There are a lot of different ways to instance geometry in Houdini, and I don't want to get involved in all of them here. But the attribute mapper could be used to randomize these properties for any type of instancing you're thinking of, whether it's changing the instance path attribute or the instance file attribute or any other method that you would want to use. I'm just going to show this method first for simplicity, and because it's also compatible with most third-party render engines, and there's still some gotchas using the other instance methods with certain third-party engines. So let's create an instance object, and this is going to be what we're actually going to create our instance points in. So let's remove this and then drop down a grid, and this will just have the instance points that we want. So the first thing I'm going to do is drop down a MOPs noise fall off, and I'm going to use this to actually decide which instance goes to which point. If I enable preview, you can see that we're not really getting a full range here, and that's because noise functions don't always give you a predictable 0 to 1 range. Every noise type is different, so it usually helps to preview it and then go into the remap tab and fit it so that you're getting a full range of noise values here. So I'm going to change the minimum until I see that I've at least got some. Yeah, it looks like my minimum is good, but my maximum, I'm not getting anything white yet. So there we go. So now I've just about got the full range between 0 and 0.5. And let's make this time varying, and why not make it loop? I'm going to just have it loop over a 2-second period. So now I'm getting sort of a full range of noises here from 0 to 1, and it's looping from start to finish, which is great. So now let's actually create our attribute mapper. And again, we have our key attribute that we're going to map to fall off. So we'll change this from integer to float. And our attribute is going to be the path to our instance object for each instance. So I can just call this instance path. And because I'm grabbing nodes in the scene that I want to instance, I'm going to use the add from ops button here to just quickly add all of those in. So if I go to my little instances subnet here, I can just grab 1, 2, 3, just point to the actual object, not any specific SOP on the inside. And I'm going to pick instance path to add it to. And so now I've got a row for each of these. Now, sometimes the mapper, depending on how you're assigning these things, it can leave these empty rows here. Like I had this default value here. That's not going to actually point to anything useful. So if you want to remove something from this table, you just select the row and then remove selected rows. And now I just have a row for each of these things. And the last thing to do is actually to normalize our key attribute. So now we get these nice distributed numbers for each of these instance types. The next thing to do is to actually assign these. So I'm going to connect this here and then connect the attribute mapper. Now, when you're point instancing, the attribute that you want to create is called instance, and it's a point attribute. So I need to change my attribute type to point, and then my match method is going to be local is less than or equal to map key. My key attribute is key, and my local key is mops fall off again because I'm using this point attribute to pick which instance goes where. The map attribute we named instance path, and the destination attribute, again, is going to be instance. And we're not going to see anything just yet because we need to jump out to object level and do one more thing to actually see these instances. But before I do that, I'm going to disable preview fall off so our instances don't get tinted. Now, the last thing to do is on your instance object, you have to go to instance, and then point instancing needs to be set to fast point instancing. And now we're going to see that we have an instance on each of these points based on that noise field. And if I hit play, you can see that it's actually now seamlessly looping based on those noise attributes over which instance goes where. And this is fully renderable as is. So as long as you have materials assigned that are appropriate to your render engine, you could swap instances like this using a noise field or really using any other point attribute you wanted without having to code this yourself. Thanks for watching and see you again soon.